Guru Prasad, Guru Prasad, please don't record right now. Whoever is recording will take permission of Ashish sir and then. Good afternoon once again and welcome to all of you. It's indeed a privilege and an honor to me to introduce the distinguished speaker for today's talk, Mr. Ashish Rathi. He is the Chief Architect of Technology, Digital Strategy and Innovation, CIO Office, Persistent Systems. Ashish Rathi handles enterprise architecture for CIO Office in Persistent, driving digital transformation initiatives to support business objectives by building cutting-edge data-driven platforms. With a focus on fostering a culture of innovation and technology incubation, Ashish leads efforts to modernize and adopt cutting-edge platforms across enterprise application groups to improve scale and efficiency in operations. Ashish Rathi has done his master's in computer science and engineering from the State University of New York. He also holds a bachelor in computer engineering from Pune Institute of Computer Technology, Pune. With a vast career spanning over 20 years at Persistent Systems, Ashish has held various technology-focused roles across delivery, pre-sales, CTO office, product engineering, and other groups. He has extensive experience in working in incubator labs, prototype development, and mentoring high-performance technical teams. His areas of expertise and interest includes cloud scale architectures, microservices, enterprise data lakes, and machine learning. Today, Ashish is going to talk to all of us on generative AI, a brief introduction. Now, I hand over this virtual platform to Ashish. We are waiting to hear you. Thank you.
Thank you very much, Dr. Sujata. Thank you for a warm welcome and a great introduction. I first of all would begin by thanking everyone from the organizing committee for having me here and for hosting me. It is my pleasure and privilege to be amongst all of you. I understand it's a very august gathering and a very diverse gathering with a lot of bright young minds in the audience. So it is truly an honor to be speaking to you all today, and I hope we can make it interesting and have fun all along the way while we learn a little bit and I get a chance to speak to all of you. So with your permission, ma'am, if you're ready to begin, I can start.
Absolutely, sir. The stage is all yours.
Thank you so much. Okay, so you've already heard, for the audience, you've already heard a little bit about me, and Dr. Sujata was very kind and very gracious to introduce me with such kind words. I'll keep it very short. I began my career about 23, 24 years ago in computer science, and I was based in the earlier part in the US after my master's, and I started my programming career with dabbling in the Linux kernel, essentially primarily a C programmer, and then I graduated to storage subsystems, RAID, SAN, NAS, and when the world moved towards cloud and virtualization, I started delving in those technologies. And then recently, over the past decade, I've been associated with big data analytics, and very recently in machine learning and deep learning, and what's out there today. So I've been here for a long time in this company, and I've looked at very technology focused roles, and that's my background, that's my LinkedIn profile. I would be very happy to interact with you all post the session as well. Okay, less about me and more about the audience. Why are you all here? And I'm assuming, Dr. Sujata, there are a lot of students in the crowd, right, today?
Yes, we have a lot of students.
So I think, why would students be here? Maybe it's mandatory for them. Maybe the reason is your professors asked you to be around. You might need the credit points here. You simply like the invite. You might want to have a little fun here. Or you might be wondering why the hullabaloo about this whole term of generative AI in the recent months. And eventually you want to learn something, right? So all of these reasons are absolutely valid and absolutely true. And if you are here for any of these reasons, you are very much in the right place. You needn't wonder why you're here on a perfectly fine, lovely Thursday afternoon. But this is the correct place to be then, if any of these reasons hold true. But truly, the reason why we are here is this innocuous looking 6-sentence introduction to a very famous technology called ChatGPT, which I'm sure all of you are aware by now. This happened last year, very recently, 4 months ago, just a little over 4 months ago, November 30th on 2022. and a small little blog post by OpenAI introducing a new tool called ChatGPT as a sibling model to instruct GPT. And we'll delve into a lot of details about these two models in the later part. But this is where it all began. And it was very, very harmless looking post saying we are excited to introduce something to get users feedback and learn. But essentially it changed the game in the last 4 months. And anybody who has been in the technology industry in the last 4 months, has been very excited. It is one of those path-breaking moments in the industry. And in my career, I have seen just 4 or 5 such moments, maybe when Google itself was launched, maybe when Amazon Web Services were launched, when microservices modeling and Docker came into picture, and now this. These are those kind of technologies that have a wide and a long-lasting impact on the way the world is going to function and the way the technology world is going to function over the next 5 to 7 years, right? So truly, this is the reason why we are all here today. So what I'm going to talk about today is generative AI. And what I'll try and cover, and I'll try to keep it, brief and simple. I know the audience is very varied and very, very diverse. So I had a tough time collating information to ensure that it is, kept interesting and relevant for everybody in the audience. So there will be some pieces of technology, there will be some pieces of, general discussion on where it is, how it has evolved, how it has come along. So I'll try to look at, I'll give a quick primer, a brief history of how we got along, where generative AI is today. We'll go a little bit under the hood and figure out how it works. We'll look at some applications of what generative AI is capable of doing. We'll look at the challenges that come along with generative AI and try and see where we are headed with this in the future. Okay. So beginning with a quick primer. Okay. What is generative AI? I think let's ask ourselves the basic question. And whenever a new technology or a new buzzword comes into the industry, we start using it all over the place. Our sales team start using it. The academia starts using it. The general people start using it. But truly, it is very important to understand what that term really stands for. Okay, because there's no true definition. It's not a standard. It is not something that comes out as an RFC or a patent or anything like that, right? So generative AI largely is any artificial intelligence that generates, and we'll keep it simple at that. That's my definition. Any AI that generates is generative AI, right? What does it generate? It generates content. What's content? Content could be anything. It could be multimodal. It could be images, video, music, or text. So any visual content in any form that can be synthesized and generated by any tool can be called as generative AI. Okay. Is there a definition? And in preparation for this, I started looking out there. Is there really a definition for generative AI? So I started, looking at the usual suspects, the biggies of the world, the Forresters, the McKinseys, the Gartners, the Tech Targets, the Geek for Geeks, and the usual tech sites that we all go to, right? And I started looking and reading, and I couldn't find a very singularly convergent definition of this, but I did find that the basic themes started converging. And if you look at, and I picked, put up a few on screen, I won't go over it line by line, but if you read them, you'll see that everything is coming together to just say whatever generates new content, text, video, images, audio, code, whatever it might be, is generative AI, right? And that's true. That is really true. Anything that generates, any content that gets generated from artificial intelligence can be called as generative AI. So what's different really between generative AI and the traditional AI that we know and we've learned and we've grown up and we've seen what's happening with AI over the last couple of decades, right? So traditional AI, for the lack of a better word, I'm just trying to call AI and machine learning as it existed before the generative AI world started picking up. I'm trying to bucket all of that together as traditional AI. And now traditional AI really functioned in the way that it was trained to whatever toolings were built, they were trained to recognize existing patterns in data. They were able to analyze this data and classify that data. And when we say classify, they were able to understand data, dimensions of data, and group them together into clusters. So all of these traditional algorithms like k-means clustering, support vector machines, you must have heard of random forest classifiers and things like that. All of that essentially worked to look at data which had multiple dimensions and then try to group those dimensions together and put the data points together. So Once it was able to do that, what it could also do is could make predictions based on that data. So if you had data which had 10 dimensions or 10 attributes, so to speak, and you had pumped, hundreds and thousands of such data points into a model in traditional AI, it could understand that when 8 of these dimensions were of this kind, more often than not, the 9th dimension and 10th dimension was of this kind. So it was able to predict. And this prediction, with a lot of mathematics and probability, made it it could be very accurate, fairly accurate. You landed up having accuracies of 90-95% in various use cases. And they evolved, and it's a very commodity technology now. It is very much out there, and it is used in various systems today, as you all know, right? Now, in generative AI, the difference is it doesn't need to understand, and recognize just patterns, but it actually can learn the patterns. And based on these patterns, it can start creating new data or synthetic data. So the underlying difference is if you have data points which have 10 dimensions and you're predicting 2 dimensions from 8 dimensions that you already know, generative AI models, I'm sorry, is there okay. I think I'm hearing some background. Yeah. So generative AI actually allows you to create data with all 10 different dimensions, which adheres to the specific pattern that it has learned. So it can have completely new data without even having any particular dimension with it. So that's the essential difference. At the very basic level, at the very fundamental foundational level, that's the difference between traditional AI and generative AI. Okay. So if I want to, we talked about what data it generates, images and content and music. And let's, just try and look at, what happens. So what I've done, so this is an image of a friend's dog, and we were out in the fields the other day playing something, and it was raining, and this dog really got muddy. And you can see this dog, and I just clicked a picture. This is an image of a cookie, which my daughter baked the other day, and it's looking very delicious. It's a standard chocolate chip cookie, goes very well with coffee. Now, if you look at these two images, there's nothing very fancy about them. They are very regular images that I can, you could see anywhere on the internet. The twist in the tale is they are not really images that I just talked about. They were not, this is not my friend's dog. This is not a cookie that my daughter baked. This was generated using generative AI models. Okay. So to even a very trained eye and even to vision recognition systems, these images will pass off completely as normal images. So this dog has never existed. It is truly built and imagined by the magic of generative AI, by computer algorithms. It has never existed. It never played. It's not a real dog. This cookie was never baked. The dough was never made, and the chocolate chips don't exist anymore, right? So while these images look very, very harmless and very real, the point I'm trying to make is generative AI has a lot of power. And just to give you an indication what kind of power this has, I look at this third image. This image is essentially, if you look and analyze this image in detail, you'll probably think this is an army soldier. Looking at the tone of the image and the sapience of the image, it seems to be a World War II army soldier sitting in a trench. Now, what's interesting is he seems to be working on something like an iPad, which clearly did not exist in World War II. Okay, so you can very easily see an image which is looking very real, keeping the theme of the entire picture extremely real, but really having extremely conflicting and paradoxical things in them. This image never existed 2 days ago. I created this image using one of the generative AI tools, popular tools out there, just trying to showcase you how easy it is to make very realistic images which are totally fake. And this is what we mean by when we say deep fakes. So you must have heard this term very, very commonly now in the last 4 months, essentially called deep fakes. So these are the examples of deep fake images, which are completely fabricated and generated using AI. Coming to text, and this is a true story. This I did recently, about 2 or 3 weeks ago. I was not feeling well. I was down with fever, and I didn't want to go to work that day. And I wanted to tell my manager that, I am going to take an off from office. But I decided that rather than sending a boring little email, I'll have some fun. And I went to one of the tools out there and told it the prompt is on the left side. I told it, you just write a leave note for out of office due to fever to my manager in the style of Shakespeare. And I'll not read the entire poem, but the poem is out there, out on the screen for you to see. This really generated everything in the correct context. It understood that you have to write it in the style of Shakespeare. It actually rhymes. It also has extremely neat context. The first two stanzas show what the problem I was facing. The last stanzas show what the manager is expected me. What am I praying to the manager that please grant me leave and so forth. So these are very interesting things that have suddenly become possible with this whole world. So coming to a brief history. Okay, how did it all begin and how did we land up here? And this actually goes back a whole lot right in the 1950s, okay, when we all know Alan Turing and the Turing machine, which is like the birth of intelligence, so to speak. Um, that's when the famous Turing test was designed. And in the 1960s and in the decade of 60s, artificial intelligence officially got recognized as a discipline of computer science. It came in the coursework, the mathematics was developed, and it started being pursued as a field for research. Um, as part of that, in the 70s and 80s and the 90s, actually, in these 3 decades, a lot of the algorithmics and the mathematics of the present day artificial intelligence systems have been developed. So expert systems, the theory bit of neural networks, support vector machines, all of these things that you're studying today in regular academic coursework, or what we are building out there in software in the industry, all of the foundations of all of these were laid in these 3 decades. Beginning in 2000s, the deep learning techniques started becoming popular. So convolutional neural networks, artificial neural networks, the ability, essentially it also happened that by this time, the hardware and the computation had also evolved to allow us to build this kind of systems and neural networks with multiple layers, because previous to this, we just didn't have the technology in terms of hardware to do all these kind of things, right? So these started coming in, and the real meat for generative AI started happening in 2014-15 timeframes onwards, when one of the famous guys in generative AI, Dr. Ian Goodfellow, came up with this concept of GANs, and he invented generative adversarial networks. I'll touch upon those a little later. These are the models that we are typically currently using, and most of the tools that use generative AI and to generate data are based on these. So in the 2020s, recently, all of this has culminated, and what we see today is the current state of generative AI. Right. Going a little under the hood of how these systems work, I would like to kind of classify whatever AI we see today and the types of generative AI we see today broadly in 5 different categories. Okay, and the first 2 are really not part of generative AI. They were part of traditional AI, but they somehow lend themselves. The theme and the flavor and the undercurrents were laid there. So if you look at rule-based systems and template-based systems, so rule-based systems are very, very typical. Where you have chatbots, where you say, even what you see on our regular banking website, say, do you want to log a service request, do you want to know about your account balance, click on something, and it will start interacting with you in chat-based system. Those are all rule-based systems. A lot of them can be developed for very simplistic use cases without really having any kind of learning at all. It could be just an if else that happens and it takes care of that, right? So these are often limited to very simple and predictable tasks. Okay, template-based systems are, if you notice, if you go to any website and you have entered your address and phone numbers and in some form on some website, and the next time you go to some other website which also is asking you for an address, or asking you to enter your phone number or your PIN code or something like that, based on the text and the label of that field and what values you've entered earlier on, it can predict that this is what it probably is that you're trying to enter. Right. So it is a little bit more flexible than template-based, than rule-based system, but it is the essential undercurrent is same. It is trying to guess what you want to do and based on the templates it has seen in the past, is actually assisting you in this. So all the browsers, the fill in the blank kind of games, autocorrect, so to speak, all of these are, largely they were based on template. I'm sorry, there was a little disturbance. Am I still audible?
Yes, we can hear you.
Okay. So machine learning models and deep learning models started coming in, and the machine learning models essentially were related to textual data generation. So anything related to text data, language models, translations, all of that is ML. Deep learning is really more in generative. So for example, very realistic output that you want to generate and things like that, all of that has started coming up with deep learning. Reinforcement learning is a complementary thing. You can have learning models sitting alongside reinforcement learning models sitting alongside deep learning, where the feedback of what has been generated is given back and fed. That data is fed back into the model to better itself, and then it can generate, get better and better by trial and error, and it can start, generating very, very clear and accurate output. And a lot of this is used in all the game playing here. So essentially, what the very advanced gaming that we see these days, a lot of that can be done by reinforcement. So a few popular implementations of lots, and I'll have a landscape of that also. But I will restrict myself to describing two of the most famous ones. One is JAL-E and the other is the very famous ChatGPT. I'm sure everybody of you must have heard about ChatGPT by now. If not heard, and not just heard, but used it, tried it, dabbled with it, at least you're aware of what's going on with the world, because ChatGPT seems to be taking everybody with storm. So DALL-E is really a multimodal AI application, and this is mostly with respect to generation of images and visual content. So it tries to understand and describe. It tries to understand and learn from description of images, and is able to very accurately generate images from descriptions that you provide. So the example that I showed you about the World War II soldier using an iPad. Essentially, I gave it a prompt saying, give me an image of a World War II soldier sitting in a trench, working on an iPad, right? And it kind of comes up with something like that. This was again built on using OpenAI's GPT implementation. OpenAI, as you know, is one of the forefront companies and organizations dealing with generative AI models today. Then after that, in 2022, the DALL-E 2, a second more capable version, was released, and it actually allows you to generate images in a very interactive manner. So if you have used it, you can start typing, it will throw up a few images for you. You can keep refining your prompts, and it will kind of keep adjusting those images until you've got something that you truly need. So it's very powerful. If you've not tried it, I recommend you do try it. It's very interesting. It's a lot of fun. Okay. Coming to ChatGPT, again, ChatGPT is something similar, except that it is mostly dealing with textual data, so mostly text content. And ChatGPT is not really, ChatGPT is actually the name for the tool, and GPT is the underlying model. ChatGPT really is a tool that combines two different technologies. One is called the GPT-4, and the other is Instruct GPT. So Instruct GPT is really the part which allows ChatGPT to talk to you in a conversational manner, understands what you're trying to say, what your prompts are, what it has to respond with, what are the instructions you're giving. All that part is Instruct GPT. While the actual content that is generated is being powered by GPT-4. And when in November, it was GPT-3 and 3.5, but recently in March, I think GPT-4 is also released. And that is what that is what the chat.openai really uses today. Okay. So if I want to go up, ChatGPT is a fairly complex tool and a fairly complex model underneath. It will deserve, a multiple day workshop to really explain what ChatGPT is and how it works. But I'll give a very, very high level 10,000 feet view. Okay. Essentially, it uses an LLM, we call it as a large language model. Okay. This is a probabilistic based model. And if you look at the screen, there is at the heart of it, there is a neural network, which is the LLM. And it is also, getting responses from, getting feedback from what it is generating as a user response. So there's also some reinforcement capabilities there. So whenever there's a prompt, the prompt is being entered, the prompt is being understood by token vector representation, and it comes, and then the model picks up on that prompt, understand what the user is trying to ask for, what data is being asked to be generated, and then the model starts looking at every single word, the preceding word, and tries to tries to predict and place the correct next word in its place. So it is a very probabilistic model. It generates the most likely word based on that distribution on where it is at that point in time. So for example, if I say, in a very, very, very simple term, if you say how are, largely the next word, the most high probability would be you, because how are you is a standard English phrase, and that would be seen in the most in the corpus of data that it has been trained on, right? At the same time, if you say how is, typically it could be how is the weather or something else, right? How is your health, something like that. So based on what data it has seen, it looks at and it computes probability of every word that is there it's going to generate, and then based on the fitments, it will start generating that content word by word. In that sense, this is an ALM, as we call it, an auto-regressive language model. It generates one word at a time and moves ahead. Okay. Now, how does it actually generate the word? That is where the model comes in, based on the GPT, the generative pre-trained transformer, which is what GPT really stands for. That's the model, and that model has been pre-trained. It is pre-built. It doesn't. It's not something that it doesn't keep being built as we are speaking, but it has been pre-trained with a previous corpus of data, and it's available now for us to use. And the third part is the instruct GPT, which I said. So how does this prompting piece work and understand? It is all the magic of instruct GPT. So that builds on the GPT-3 language capabilities, where it allows natural language processing, where it allows this tool, Chat GPT, to understand, make sense of what the user is trying to ask. If you say, pretend you are my financial advisor, so it understands what it means by the user saying you pretend financial advisor. So it understands the Chat GPT should now take on a role of being a financial advisor and start looking at content to be generated, which is more financing in nature and things like that. Okay. So this is largely the view, and there's a famous picture which has been built trying to compare Wolfram Alpha, which was an earlier tool that came in the 2000s, a very popular tool at that point in time, with the technology at that point in time, versus what. And I have some references towards the end. It makes very interesting reading. But this is at the heart of ChatGPT. This is how it functions. Now coming to the training data of ChatGPT itself, what has it been trained on? How does this model function the way it functions? Okay. So the training corpus, and this data is not easy to come by. It's not declared in the public domain. I've tried to collect it from various sources. Really, the exact values are not available out there. But this is from whatever we know from what people are talking about with ChatGPT. So the training corpus contains over 45 terabytes of text data, which is huge. Textual data of 45 terabytes essentially means almost the entire internet if you look at it. It is sourced from a wide range of sources. So books, articles, web pages, and everything that is blogs, everything that was there that was available for grab as text data has been taken. Multiple languages, these are the main ones, but it's there. I'm sure that it is trained on a whole lot of other languages as well. It is very diverse in terms of topics and domains. So it covers everything with respect to data, from science to technology to literature, history, medicine, finance. Pretty much every single topic that is there and every single domain that is there has been used to train the model. Some stats that we've seen is about 175 billion parameters with more than 8 million unique tokens or words are there inside the model to make it to ensure that it is able to predict and put forth its probabilistic calculations on what should be the next word. This is the amount of data it has to think through those probabilities. And then what we know is it has probably been trained on Microsoft's Azure infrastructure using very powerful NVIDIA GPUs. This seems to be the training data for ChatGPT. They have restricted ChatGPT to use data up till 2021, I believe. So it is not very updated with recent events. So if you ask ChatGPT anything about recent affairs, it's not being able to, it's not going to be, telling you anything about that. And the reason for that is it takes, huge computation power to train that model and keep it, very recent. And it will keep on happening. I'm sure it will keep on happening and it'll keep on training that model. But there are technical limitations to do that so quickly. So we talked about text. So, but I also showed you some images of how images get generated, and then that is done using something called as GANs. These are generative adversarial networks. These are really at a very, very basic level. This is nothing but it's a very simple idea to understand. There are two neural networks, and neural networks, as you know, are very standard in machine learning, where you have, or deep learning, where you have input, a series of nodes which process this input and strengthen the input or weaken the input and generate an output. And there could be multiple layers of these things, right? That's a single neural network. The GAN really works two neural networks which work as friends of each other. Okay, they work as enemies while working to generate output, but once the output is generated, they become friends. And what do I mean by that? So essentially, when you want to generate image, the lower, this is one network, this is the other network. The generator starts creating images and starts throwing up data. The discriminator, which is the other network, actually starts to see whether it can understand if this image is fake or real. And hence, it actually tests what its friend is doing. So the generator keeps generating, the discriminator tries to keep on testing and figuring out whether it is fake or real. And they work in tandem, and this information is fed back again to the generator, and they kind of try to outdo each other. And eventually they converge at some point where both of them agree that this seems to be the correct output. And hence, the final image comes out to be very realistic because it has passed the level of the discriminator as well. Okay, so this is how the generative adversarial network, and that is why the term adversarial is there in the name, because they work as adversaries of each other. But eventually, when the final result comes out, they make friends and they make peace with each other, and allow an image to be generated outside. Okay. If I come to applications of generative AI, and there are a whole lot really, but just to touch on a few various domains, and this is what we could just think of in the last few days of a few months of what generative AI is doing. But content creation, we've already spoken about that. Text, images, video content, essentially in marketing, advertising, content generation, digital marketing, entertainment, gaming, all of those areas. Chatbots and virtual assistants, the ability to ensure that how you interact with computer systems can be at a completely different level with respect to making it very conversational, very, very human-like in its response. So wherever you see chatbots and virtual assistants, that entire game can change with GPT-4 coming in now. Creative arts. So actually, this is a very interesting thing. It can generate completely different, completely new art, paintings, portraits, synthesize music, videos, anything, right? It can generate all of that. And there's a whole, this has forked off into a very interesting debate of who's the owner of that art, right? Who's the artist? Is it the AI? Is it the person who's actually instructing the AI? So there are a whole lot of ethical and, very interesting questions that are starting to coming up in this area. Simulation and modeling, figuring out weather forecasting, traffic flows, any other complex system which need a lot of synthetic data. So for example, you could generate data entirely about a cyclone and then tune it and see how it would behave, right? So you don't need to worry about getting real data about 100 different cyclones now. You would be able to figure it out and ask generative AIs to generate data that models the cyclone. Virtual environments, so anything related to immersive virtual environments, the virtual reality world, that can happen. Healthcare is a big area. So drug design, having one of the many challenges in drug design and healthcare and advances in healthcare is you don't have data available to quickly understand how your drugs are going to act on or respond to, and or how the cells are going to respond to that. So with this kind of power of generative AI, you could essentially generate a lot of synthetic data, which otherwise you wouldn't be able to source, and then base your trials on a lot of that and see how everything is going to respond. So a lot of work can happen in terms of coming up with new drugs, understanding how new drugs interact with the human biology, how a disease will progress, predicting what patient outcomes would be, and so forth. Robotics is a no-brainer. It was always something that has been associated with AI, and it continues to be there. And a lot of areas like subsequent fields like banking, fraud detection, customer service, all of those also can benefit greatly. Essentially, looking at if I can develop personalized financial plans or insurance plans, based on data that it has seen and based on data that you tell it that I'm of this kind. What kind of a financial plan do I want? Looking at all of that, it could generate an entirely new customized financial plan. Okay, hitherto this was not possible. Okay, moving ahead. Yeah, so this is what I was mentioning with let me just zoom in on this. So if you see, this is a very famous picture from Sequoia Capital. This is giving you a list of tools, companies, organizations that have mushroomed over the past few months in various areas of generative AI, whether it is text, whether it is AI assistants, anything related to support, video generation, image generation, code generation, speech recognition, you know, multiple startups, established players. You can see GitHub Copilot, which is a very, very famous, tool that is coming up recently, which is going to change the way programmers program apparently. And so if you can see, in a very short time, this has just mushroomed, multiple people with multiple ideas, and the possibilities are endless here. And, all of them are based on OpenAI's DALL-E 2 and these kind of models, ChatGPT 3, GPT-4, 3.5, all of these models, all of them are being based on this. Okay. So far, everyone with me? Am I going too fast?
I think the pace is proper. If somebody has difficulty, please put it in the chat.
No, sir.
All right. Okay, so moving on the challenges here. So I took the liberty of a very dear friend, Dattaraj Rao, who is a chief data scientist at Persistent. We work as colleagues, and there was a recent article that he wrote in the Times. The link is right there on the screen. I urge you all to read that. It is very interesting. He's given his perspective on what generative AI is and what the future holds. And I'll try and pick up some of the themes that he has said. With his permission, I talked to him about this. And essentially, I'm trying to bucket what challenges we see with generative AI in, coming up with what it's possible to do with generative AI. So legal, one of the first things that is a legal challenge. I talked about deepfakes. I was able to generate images very quickly, very realistic looking images. So this obviously gives this whole business of creating and distributing false and misleading content, not just images, but even video, and at a lot of times even audio. So you could have, telephone conversations being faked completely using these kind of technologies. And there could be a lot of unfairness in generated content. So you could make, based on tuning the model and the parameters, you could make content to be very one-sided or very unfair in some sense. So a lot of legal aspects coming, and how do you control all this, and what does it mean in terms of ensuring what is true, what is not true, all of that comes in. There are a lot of ethical challenges. So, with the world we live in today, with social media, with things like Twitter and Facebook and the Instagrams, and things that anybody has the ability to make anything viral very quickly. How do you ensure that content that is out there is not having any biases and discriminations, right? So because you could generate content and synthesize content very easily, it could also make it very biased and very discriminatory towards certain kinds of people, towards certain races, towards certain countries, towards anything, right? And all of this can be used for propaganda, whether it's political, whether it's cultural, whether it's religious, whatever it is. So there are a whole lot of ethical challenges on how do you control this kind of power that has the ability to generate what you want. Okay. The other important thing is there could be a lot of inaccuracies and factual inconsistencies. So one very, very important thing to keep in mind, and I talk about this to everybody who's using ChatGPT these days, is um, it is not a search. It is not Google. It doesn't work the way search engines do, right? Search engines actually give you whatever you have typed. It will try to match those exact things, or at least try to rank the most matching things in a particular web page and present you the web page as it exists. It doesn't change anything there, right? It might be a good match, bad match, whatever, but it doesn't change anything in the truth or the source from where it is taking, right? These kind of models are generating output for you. This is not really searching. It is just giving you output based on what it has seen earlier. The output could be true because most of the things that it has seen earlier is true, but at the same time, the output could be extremely false and could be completely fabricated as well. And this is a very real possibility. So it is essential and very, very important to understand that what you see as output from these kind of tools may not be 100% accurate and maybe actually be generated and synthesized. And how do we kind of tackle that moving ahead? It becomes a very interesting problem to solve. Okay. The third is security. You could have a lot of impersonation. I just talked about that. You could actually have audio in somebody else's voice talking, something that really never happened. Or you could have video, or you could have images, and this was there all over the internet a few days ago. I'm not sure, but many people must have seen some banter that happened between Elon Musk and the Catholic Pope, and there were a lot of things, a lot of images that got generated which were fake. Malware generation. Anybody can actually look at ChatGPT and ask it to say, how do I create a malware? Give me the code and how do I publish it? And it's out there. That information is out there, right? In addition to that, there are a lot of technical challenges. So a concept called as hallucination in the world of deep learning and generative AI. So the model starting to hallucinate. It because of the data that it has learned, and because it is a probability at the end of the day, it is all probabilistic. It can be semantically and syntactically correct, but yet the data could be completely nonsensical. Okay, so how do you avoid these kind of edge cases or those outliers? That's a technical challenge. How do you keep training these kind of models? How do you build on a training data corpus? How do you ensure that things that you don't want to be in the model, things that are illegal, things that aren't unethical, those kind of information doesn't come into and get into the models to be available out there? So how do you ensure that people are not able to bypass the models, parameters, and tunings, and with backdoors, and to get it to make it work with things that are really not legal, and so to speak. Okay, so these challenges do exist. Now, coming to, this question is being asked all over the internet, and a lot of people and a lot of young people that I talk to are even not just young people, but everybody who's out there in the industry. Will AI replace engineers? Now, this is a question, and I really truly don't know the answer to this question. Okay, it may not, but I personally don't think that as engineers we should be worried about it. I believe most of the audience today are either engineers or engineering students and are working towards the domain of computer science. I don't think this is true. And just to keep it very simple, and for all the young people who are attending this call, a few tidbits from my experience and from what I talk to with young people. uh, for Don't worry about whether AI will replace engineers or not. What I would say is keep a few things in mind as you move into the industry. First is, don't focus on code. Don't think about how do I write great code in C++ or Java or Python or Golang or Rust or whatever is out there. Understand how to program, and there's a very subtle difference. Code anybody can do. It's all out there. It's not just GPT, but even there were a lot of tools that were existing earlier on in very early time frames also. For example, I believe if people are from my who graduated during my times, there were a lot of tools called UML tools, which you could drag and drop, a class diagram, and it could generate Java code for you based on those class diagrams, right? So coding is not a problem. Learning how to program. If you are not able to generate a great class diagram, then whatever kind of code you write is not going to make sense any which ways, right? So understand how to program. Don't focus on learning how to code. Understand the principles of programming. And I'm sure that many of you as engineering students might know that there is usually a subject called principles of programming somewhere in the third year or fourth year of engineering. And at least in my time, it used to be there. It could be there in some form or the other. But I think it doesn't get the credit that it really deserves. It's an extremely important subject that teaches you the basics of programming and doesn't doesn't bog you down with a particular language. And that's very important. You've got to learn how to use the best tool in hand and the best weapon at that time for something. Don't be, if you're a Java programmer, you'll always think in Java and you'll not be able to think about using something else which is really better at solving the problem at hand. So if you know the principles of programming, you're better, you'll use the best tool available at that point in time. And that is what makes a good engineer, right? Be strong on fundamentals. This is very, very essential. Don't get lost in the jargon of technology. Be very strong on fundamentals. Be every new engineer coming into the industry, you can very easily see the people who are strong in fundamentals, who understand their basics, really are the ones who stand out and move ahead very fast in their careers. Okay, so don't disregard things like, why will I need to study algorithms, because who works on algorithms these days in the industry? No, that's not true. It is very important. The basics are what are going to keep you ahead and ahead of the curve. Always remember that AI is artificial. At the end of the day, it is artificial. It was built by engineers and scientists like you. So if you can build something like AI, obviously there will be more things that you will be able to build, and hence there will always be jobs. And hence, as engineers, you should more than happy be consumers of technology, but also ensure that you are competent, relevant, and trained to be creators of technology. I think that's what is really key. So I wouldn't worry too much about whether AI will replace engineers and coding jobs. No, I don't think for bright young minds and competent engineers this is going to be a threat at all. Engineers will be engineers. We are going to build, and we will continue to build. Okay. There are a few references here. I think with that, I'm kind of coming to the end of my talk. It's been a monologue so far, but I think we've got another 10 minutes. So would love to hear from you all what you guys think, if there are any questions. Oh, this is the last one. This is again one of my attempts at humor. I tried to use DAL-E to see whether I could create an image of Einstein using a mobile phone. And I saw that he also uses Android. It generated this for me. So with that, I would like to end my talk. My coordinates are there on screen. You can reach out to me on Twitter and LinkedIn. My DMs are open, and I would love to interact with you all. If you have any thoughts, feedbacks, questions, I would love to hear them. Okay, that's all from me. Thank you.
Thank you, Ashish. It was wonderful. You made the session very interesting, very informative, very colorful also, right? Generating a lot of interesting pictures for us to do the fun. So I think this is the time now for our audience to ask questions. I think they can unmute themselves and feel free to ask questions. Yes, audience, feel free to ask questions to Mr. Ashish.
Hello, am I audible?
Yes, you are.
Hello, I am
Yes,
Dr.
sir, please.
from Jyoti Institute of Technology.
Yes, sir.
Sir, I just wanted to know, with the current trend of this AI going forward, is it really healthy for the community as such? Because the kind of research is happening in AI, and I think I feel that it's more detrimental to the common man rather than being constructive. Your remarks.
Yeah, I mean, you're right in saying that in some extent, and it's a very interesting debate that is going on. I think as with any technology, whenever we see something path breaking and something that seems to have immense power, there are always two sides. So I wouldn't want to compare this with something else, but if you look at, nuclear energy, the same debate happened. It is destructive, and at the same time, it is a great enabler, right? It could actually solve the world's energy problem, but at the same time, in the wrong hand, it goes anywhere, right? It is something similar. AI, with the advances that have happened, it has, with great power becomes great responsibility, as we all see. So there is no true answer. I don't think, though, that it will be, in some cases, in fringe cases, it might be detrimental. But if you look at the abilities for it to help in medicine and healthcare, and in general betterment of or advances uh, in areas which can better human life, I think it will also do a lot of good. So yes, it's a very mixed answer. It's yes and no, but largely yes. I would lean towards, it generally should make us better as a society, keeping aside the fringe elements.
Yes, sir. Thank you, sir. Thank you. Thank you.
Any other participant would like to ask? I have a question for you, Ashish. It's very
Sure, ma'am.
interesting. It has both positive sides and negative side. I agree. Technology is a double-edged sword, and it's like how we try to use that to our benefit, in general benefit to the humanity. I totally agree with that. Basically, are there any legislations and things like that which will have to be brought in when AI tries to grow much further beyond? Or are there any countries which have thought of some legislations that should be brought about, probably to differentiate between deep fake and actual things, which is all very required, I feel. I just want to understand more on this.
Yeah, so no, that's a great question, and I'm not sure. I'm not the authority to answer whether the legislations have happened or not. But I did, and I'll just give you an insight of what news I've been reading. So I read recently that Italy has, banned certain parts of ChatGPT because it doesn't seem to, because they are not happy with the privacy constraints of the model. Okay, what data it is learning from, what it is being fed into, and what goes back into the model. They were not very convinced about that. So they did have some regulations coming in from the government directly. Okay, there was a consortium in the US. I've been reading it in the news. It's been all over the place. Of a few, very few, or a lot of eminent scientists and mathematicians and industry leaders have come together and asking for stopping any advancement in AI in general. I don't know how much truth there is to that. But of course, I am very sure with the ability of these deep fakes coming in, and with the social media, there will be a necessity for legislation. If not legislation, a side, a complementary area of technology will develop, which will allow us to tell whether this is a fake or not a fake, right? Otherwise, it will become a very chaotic world, so to speak, because it can, propagate false information very quickly. Right. So I'm very sure that legislation will come. See, this is very similar with cryptocurrency, right? When cryptocurrency came up, people didn't know where it was going, and then didn't have regulations to, govern that. But as it became, very commoditized, and it went to a certain critical mass, almost every country in the world started having legislations coming for cryptocurrency. Same thing will happen here as well. And it has to, because it has to be governed somewhere over here.
I totally agree. Probably people will start working more on it, or thinking about, how to curb the negatives of it, probably the use of technology again. Thank you. That was wonderfully articulated by you. Thank you.
Thank you very much.
Any other participants who would like to ask some questions?
Excuse me, sir.
Yes, sir.
Sir, is fresher come become a engineer?
I'm sorry, sir. I couldn't get your question correctly. Would you repeat it, please, for me?
Is fresher can become an engineer?
A fresher can become an engineer. Is the question here?
AI engineer, sir. Artificial intelligence engineer.
Oh, yeah. So you're saying whether a fresher can become an AI engineer, right?
Yes.
Well, I'm not sure I completely get the theme of the question, but an engineer is an engineer, and if you have the fundamentals as you're saying, why I don't see anything stopping any engineer or any stream of engineer to adopt to this technology and become an AI engineer. Of course, you have to understand the theory behind AI, that is for sure. It is not about consuming technology but creating technology, so that for sure. But the information is out there. I mean, I don't see why any fresher cannot be an AI engineer in the future.
Do you have anybody else who want to ask Ashish some questions? Please unmute yourself and ask. Feel free to ask questions. You can even text it in the chat box. I'll read it for them. I mean, read it for Ashish in case you would want to.
So actually, where should we learn those technologies like machine learning, deep learning, neural networks?
Well, it depends on the phase you are in. If you are an undergraduate student, a graduate student, I mean, there are various coursework, of course, is one thing. But if you look at machine learning, one of the most famous courses for machine learning is by Professor Andrew Ng, who comes from Stanford, and he has a very, very famous machine learning course and multiple books there. That's a very quick, very popular resource to start learning these technologies. With respect to actually going deeper, there is no end. There are a whole lot of startups and different courses and different universities doing different kind of research on this. So once you get the basics, then it's up to you to find your own path and see whether you want to get into deep learning or generative AI or any other fields of machine learning which are out there.
Okay.
It's a lot of mathematics. Obviously, underneath a lot of mathematics comes in here. So one of the basic requirements would be to have mathematics and computer science background at some level or the other.
Yes, sir. Any specific websites to learn?
Well, not really. I think Andrew Ng's course is one I would recommend. I think that should be out there on Udemy also. But if I find any specific ones from my network, I can definitely share it with this forum as a follow-up.
Thank you.
Thank you. All right, I think we are 2 minutes over the call time. So if there's nothing else, then Dr. Sujata, I would again like to thank you all and for being a very great audience and some interesting questions. And it was really an honor talking to you all today. Thank you so much.
Excuse me, sir.
There's one more.
Hello.
Yes.
Yes, we can hear you.
So, what's your LinkedIn ID? Means
yeah, my LinkedIn, I'll share it. It's Ashish Rathi, and if you just search for Ashish Rathi Persistent, you should be able to find it online.
Okay, thank you, sir.
Yeah.
Any other questions? Thank you so much for a wonderful presentation, Ashish.
Thank you
Ashish
so much.
Rathi. Sorry, I pronounced it very in the wrong way at the beginning.
No, not at all, ma'am. That's okay.
Thank you. I learned about it. Thank you. Thank you for a wonderful presentation and giving a lot of insights on to generative AI. I think people are more, have more clarity now after hearing to your presentation on generative AI. That is what I understand. Thank you, audience, for all your participation in the Bytes Expert series today. So, thank you, one and all. Have a nice day.
Thank you very much. Have a great day.